So the quadratic formula is useful for what? It's useful for solving ax squared plus bx plus c equal to 0. In other words, it's good for finding zeros or roots. Okay. And there's a formula for this. Do you guys remember the formula? It's there's all these ways people have to remember it. The version that my old student taught me was they said there was a negative boy. He was unsure if he wanted to go to a radical house party. The boy was a total square. Oh no, the house was filled with boys that were total squares except for 4. Awesome. This is a derogatory term, I think, but chicks. This is, again, a student told me this. And the party was over by 2 a.m. I don't know if you have a better one. Students teach me all sorts of interesting things, but that's a quadratic formula. Okay. Oh, what happened? What is this? There should be something here, for example, too. Hold on. Let me just write in the stuff for you. So let's do, you have something on yours, right?
Yeah.
Okay, it's okay, I have it.
Okay.
Let's write it in here. This is f of x is equal to 2x squared minus 4x plus 1. And g of x is equal to negative x cubed plus 3x squared plus 4x. Okay. So I am not going to do all 3 parts of this just because I feel like this early part is going too slowly for my tastes. But I don't want to not explain things either. So we're not going to sketch the graph and we're not going to find the zeros necessarily. Let's just talk about the behavior at infinity. And maybe we'll find the zeros of part B. Okay. So when we look at this f of x, basically I need to look at the leading term. And the 2 in front is positive, so that doesn't change anything. This is positive. Okay. So when I go to graph this, I know that the basic shape is just going to be something that looks like this because we have an even power. The leading term is even. So I already know what the basic shape of the graph looks like. And then to actually answer the question, I'm just going to say, as x goes to positive infinity, the y values are also going to positive infinity. As x goes to negative infinity, the y is also going to negative infinity. Does that make sense to everybody? So part of calculus, we're going to learn how to graph something like this very accurately.
Professor, I have a question.
Yes, what's your question?
Shouldn't the y be going to positive infinity also?
It should. What did I write? Whoops. I would pretend like I was trying to test you, but that was just a mistake. I just, I wrote something wrong. Thank you. This happens all the time, by the way. Let's look at the g of x1. So when I look at this g of x1, this is the leading term. But this time, when you look at this leading term is negative. So what happens when you multiply by -1? What kind of transformation is that? Do you guys know?
Linear transformation.
I agree. This is something that we call a vertical reflection. if you think about it, you're multiplying all the y values by -1, right? How do you spell reflection? Reflection. So when you multiply the y values by -1, if it was something like this, can you see me? If it's something like this, then the positive parts become negative and the negative parts become positive, right? So it's like a vertical reflection. Okay, so that's what the negative in front there does. So we know what the basic graph looks like. We know that the basic graph is going to look something like this. But that's the positive version. When I multiply by the -1, that actually looks something like this. Right? So then what we could say is we could say as x goes to positive infinity, y looks like it's now going to negative infinity, right? And as x goes to negative infinity, y goes to positive infinity. Does that make sense? So I think anytime you see a polynomial at this point now, you could sort of look at the polynomial, try to figure out what the leading term is, and you know the rough shape of the graph. You just don't know all the detail. Okay. Any questions so far? So let me show you something on Desmos again. So I just want to tell you where we're going with this course. So the first example that we did was 2x squared minus 4x plus 1. Okay. So this is not so difficult to graph, but we can use calculus to figure out exactly where that bottom point is. We can use algebra to figure out what the x and y intercepts are. Actually, quadratics are not so difficult to graph. But if we look at the graph of the second guy that we did, that looks like y is equal to negative x cubed. Then we got plus 3x squared plus 4x like this. Oh, this is much more interesting. So this is the shape of the graph. As you can see, it's sort of like a flipped version, a vertical reflection of the x cubed graph, very roughly. But if you look, there's some point where it hits like a local minimum near 0. So, there's right near 0, right to the left of 0, you see the very bottom of that hill. And then right to the right of 2, you see that the top of that other hill there. So when we learn calculus, we'll be able to figure out the exact locations of those two, the trough and the peak. And calculus will help us do that. So we're sort of working towards that. Okay. So I just kind of want to explain that to you guys. So let's just find the zeros of B, because I didn't do a single example of finding the zeros. So if I were to look at B continued, what do you suggest I do first when I look at B and I try to find the zeros? Any thoughts?
Set g of x equal to 0.
Oh, that would find the intercepts. Oh, wait. You're right. Sorry. I mean, you're right. Never mind. We are finding the intercepts, so I wasn't thinking you were going to say that, but okay. Yes, for sure. 0 is equal to negative x cubed plus 3x squared plus 4x. And what do you want to do next?
Can you factor out the x?
Yes, that's what I was hoping someone would say. So, you know, always look for the greatest common factor first. Do you want to factor out the x or do you want to factor out a negative x? It doesn't matter, I'm just curious. X, she said x, so we'll just factor out the x. So you get negative x squared plus 3x plus 4, right? You know what? I wish I'd factor out the negatives. Let me factor the negative. I don't like working with the negative in front. So that's going to change these signs. It's going to make this negative and this negative. And then this will just be negative x. Oh, this thing factors perfectly, so I didn't use the quadratic formula at all. Oh well. This is x minus 4. This is x plus 1. Right. So in the end, we get that our x values are x is equal to 0, 4, and -1. Because we have each of those 3 factors, right? So this first factor is basically saying when x is 0, the whole thing's going to be 0. The second factor is saying when x is 4, the whole thing will be 0. And this third guy is saying when x is -1, the whole thing will be 0. Does that make sense to everybody? Any questions? All right, great, cool.